Well, welcome to the June meeting. It's good to say, I know we're a small group tonight, but it's going to be an exciting meeting all the same. Hi, Nancy. How are you? We didn't get to say hi to you yet. You're looking summery.
Yeah, it's hot down here. So, hair's been in a ponytail all day, and I'm in the middle of baking bread, and well, actually it's rising right now. And so have granddaughters. It's been a good day.
Good. And baking bread, what a fun activity to do with children. I love it.
Well, that's how I do bread anyway. So I bake my own bread and cookies and stuff like that.
Awesome.
Yeah.
Well, welcome everyone, and it's going to be a good June meeting, and we're getting our first warm day here in Chicago as well. So hopefully, there's Diane joining us. We have a packed agenda. Sally's going to share more about the PEAK program at her school, and then we have Paul Higgins here with us from the Sunspotters project, and so he'll be presenting that. So that should be very, very exciting. It's a brand new project with Zooniverse that just launched. So we're excited to have him with us. But what are people's summer's plans? What is the thing you're looking forward most to this summer? If you can tell us in just a couple words what it is you're looking forward to most. Yes, I please meet carrot and celery. You'll see celery's they have come from Wisconsin to live here and be urban cats now. So carrot, it's dinner time, and they're a bit mad. So anyway, things we're looking forward to most.
I'm going on a road trip with my dad. We're going to go about 2,000 miles or more. We're going to go up to Jasper and come back through Banff and Lake Louise. And I have a star party that I'm doing in Waterton. And so we're taking the long way to get to that. And I hate to say that comes on first over. I'm looking forward to Maven, but spending 2 weeks with my dad, that's going to take the cake.
That's going to be priceless.
Well, this is my oldest granddaughter, Carly. So I hope to say that. Hello. So she's 12, and she's hanging out with me today. And this is what I do a lot over the summer. Is I call them my girls. I have my granddaughters over the summer, so that makes life fun.
Mm-hmm. Yes.
Terribly unfortunate that you don't have beautiful grandchildren.
I know, isn't it? Yeah, they're very pretty.
Very pretty.
Thanks.
Well, I just completed a trip to Michigan to see family after 4 years, and that was really exciting. So, and it was really cool. So it's been a long time. So, and then of course I'm looking forward to Maven, and then all the music I'm doing this summer. So, and my granddaughters. So.
I'm looking for 3 sunny days in a row.
The tall order, Vic. I don't know. Scale it back a little bit.
Just 3.
Well, I'd kind of like some of your cloud cover and rain, because we're already in the upper 90s down here. It's hot.
It was 40. It's 41. It's cold.
We don't even get that. Well, maybe we get that from, I don't know. Molly, you can help me out on this one. I think we get that sometimes in the wintertime, not terribly often. 46, geez.
Days ago at night, we got down to 44 degrees in New Hampshire, so it gets cool. And that's
I just signed on, so I don't know what you guys are talking about right now.
It's just sharing what is the activity you look most forward to in the summer?
Oh, yes. Probably being cool in the water.
Diane, how about you?
I like to try to catch the sunrise on the beach. I want to catch the sun as it comes up over the horizon. And then I always have my camera with me to catch it.
Do you ever see a green flash?
No, I have not. And I didn't understand that about half the time when I go down there, there's cloud cover. And when that eclipse occurred last November on my birthday, the clouds kept building in front of the eclipse, so that our seeing it was actually delayed by several minutes because it had to get above the clouds for us to see it. Yeah, someday maybe I'll catch a green flash, but I really wouldn't expect to catch it from here. So, and it was a meteorologist from Florida State that explained to me the reason that I had such a dodgy time trying to catch sunrises and moonrises is the fact that the Gulf Stream is out there putting those clouds up. I was like, oh, I never knew. So that's my fun plan.
Laura, I don't know if you have a microphone or not, and my chat window is gone, so I'm going to have to log out and log back in again to get it back. But did you put something in the chat, Laura, or did you? No. We'd love to hear what you're looking forward to. Ricky or Nancy or Don?
Oh, well, we just started our RU, our research experience for undergraduates. It's our first time running the program here at the lab, so we're very excited about that. And the first 2 days have gone great. So Claire won't be here because she's still running it. So I know she's very excited about it too.
Well, for me, work-wise, I'm really looking forward to, we've got some professional development sessions that we're running at the ASP conference about diversity. So I'm really looking forward to that. And personally, I'm looking forward to camping in the summer. I've got some camping trips planned, and I'm hoping for good weather and some good campfires.
I'm looking forward to going to Cancun for the summer with my family. I've been working past 2 weeks. Rice had a grant to open up a middle school for teachers summer institute. So I was asked to go on the team and write curriculum for the science and math teachers. So we've been up there for past week and a half, and it's been fun. And I didn't realize how challenging it was to write a curriculum before to incorporate math and science, because we're in our own little world in the science world, and the math and all the other teachers are in their world. And when you have to sit down and try to write a curriculum that incorporates both, it's a little challenging. But it was really interesting to finally get a lesson down and one more to go. And then in July, the MAVEN Mars mission for NASA. So I'm excited to be able to go to Colorado, where it's nice and cooler, hopefully in Boulder. And then shortly after that, we'll be going to Cancun, my whole family. So I'm excited about that. So that's what I'm looking forward to this summer.
Nice, excellent. Don, you have any summer activities you're looking forward to, or Paul?
I'm looking forward to traveling a little bit, and like Nancy, I'm looking forward to camping, spending some time outside.
Personally, just the fresh produce in California is finally back, so that's nice. Other than that, just publishing papers.
Such good things happening. Well, summer is a lovely, it just always feels different, even though so many of us, I know teachers don't really get work off. That's celery, by the way. They're going to be obnoxious. I apologize up front. Anyhow, so Sally, I would love for you to pick up where you left off. And last time, Sally shared with us a little bit about our school and the PEAK program that runs for the middle schoolers. Is that right, Sally?
Right. And I'm going to go share screen right here. Whoops. Share screen with computer sound. Yeah.
Okay.
Whoops. Okay. Now, I have a PowerPoint, and I didn't download the PowerPoint because I realized when I finished the end of it, you wouldn't have understood because it wasn't complete. I do want to go back a little bit just to review what PEAK means, the acronym. Here we go. It's a middle school program for 5 months. I teach in a sports academy school, and so it means the PEAK acronym is pursuing and engaging in authentic knowledge. And so where I left off was some samples that I wanted to share with you on some of the curriculum connections that we were able to accomplish.
And
When,
Sally, if you go to the presenter mode of PowerPoint, it will take up our whole screen so we can see your lovely slides even better.
oh, okay. There we go.
There we go. Nice. Thank you.
Here. Okay. So having a school for 5 months, it's a sports academy school. And so when we design, kids sign out and of their home schools and then sign back in after the 5 months. The two pieces of curriculum that we do not, that we keep the same for their sending schools would be their foreign language and their math. And then we play around in a sense to make connections. So some of the samples that I want to show you is in health, we made, I designed this like science, we made prosthetic hands. And the object was to find some objects, find some materials, and make sure the hands are able to grasp and pick up and let go. So they are in control. So they were doing this. And we tie that in with space, doing the, robotics with, they have to find, find robotic hands to do things, which they're doing in the International Space Station or eventually for space exploration. So we try to make those connections. 1 year we worked on the book Endurance. That's, if you're familiar with that, with the Shackleton exploration. His goal was to go through and travel the South Pole land-wise and be the first to do that. And his goal changed when they became stranded. So then his next goal was to have all 27 men survive, and they were stranded for 22 months. So when you design curriculum, you try to use all the local resources that you have. So we happen to have the lady here that's on the upper left-hand corner. She was fact finder for the book and the movie. And so we were able to go to Dartmouth College and look at one of the diaries. All the men, all 27 of them, had actual diaries, and there are 4 left. And one of these actual diaries is at the Dartmouth College. So we got permission to look at that. And what they ended up doing was searching out things. The students were amazed at the handwriting and the size of the diary and the cursive writing and the keeping track. I have a whole slide presentation on the contents of the diary. And they ended up looking up on their birthday, what did these people have what did they have to eat or something. And then along with that, when you study, we went to see the ice cores. So we have an ice core model here of 250 years old, and then one of 8,000 years old. And so tying that in with the cryosphere, which we did the study of snow, we were able to see that and view that. And then we had a lesson, which I got from, and I downloaded this for you on it's called Talking About Absolute and Relative Dating, because it gets kind of abstract. So how can an ice core capture information? So this lesson, which you already have, was designed by this fellow, Zach Smith, and I just thought of it. He'd be a great resource for us. I have to contact him. He's just an amazing guy. He designed this lesson, and in the lesson he says you get all these little pieces of paper and you shoot them and they fall down on this. This happens to be Antarctica on that second slide there. And then you put pieces of paper representing the years so that the kids get an idea that there's different amounts of the paper represents dust or chemicals or particles, so that they get a count in a simulation of how you gather data from ice cores to relate to climate change, to relate to what's happening several years ago. And on the Chandra website, there's an actual activity with ice cores that uses real data. So I just mentioned that. I didn't include that website here, but that's would be a great tie-in for this kind of an activity. So one of the things that I did a couple years ago was this weather and climate study, and I did it out of the University of Nebraska. And I used what they call a 3D transit study. And this was also designed by Zach Smith. And I downloaded that activity of how to make these. I used to do 3D transit, not 3D, but a transit study at the tide pools or in a field, and I only did it by 2-dimensional. And then realizing that when you study a space, there's depth to it. So then we designed these cubes, and you can do anything with these cubes to design differences in weather, different places on your campus as to wind and temperature. You could create your own little greenhouse. It's amazing the kinds of things that you can do. You can do them in water and out of water if you were near water or near the coast. So these potentially, I have these, this is an example of the students building these, and then they're putting up their equipment. And that's basically the final things I wanted to share with you. I shared with you the unit, wait a minute. Okay, here we go. This unit of each of the lessons, and all of the links to the Wright Center in Tufts University do not work. So that's one of the reasons I downloaded for you individually on the folder that I did, 2 days ago? And then if you have any questions when you read through this, I want to get out of this right now and show you the, wait a minute. One more thing to show you. So if I get out of the PowerPoint, here we go. Here. This is the unit study that I have. So there's series of lessons here that I shared with you, and most of these links will work. And these PowerPoints, if anybody needs any of them, I will search them out and download them for you. I didn't do all of them because there's about 4 or 5 on here. And the students did a weather challenge and a climate challenge for the community at Waterville. And so they followed through with that. So anyway, I keep each year doing something different, and it's evolving, and I hopefully will be, when I learned from the Maven mission, that's certainly going to be an intricate part in November when I get back there to start teaching again. So that's it.
Incredible, Sally. What a labor, and yet so rich is the word I think I'm looking for. Is how lovely. Anybody have any questions for Sally? I know Sally has really done a wonderful job of getting things posted to the Widgeo, and I will make sure that it gets into its own folder labeled with your stuff. But does anybody have any quick questions for Sally before we?
Which school is this at? Sorry, I missed that.
Waterville Valley Academy. Just a minute. I didn't bring up the website. Here, let me find my PowerPoint. Oh, what did I do? I checked out of it. Can I go on? Here, hang on.
Yeah, your computer works the same. We can see whatever you're doing. So.
Oh, I didn't want that, but I just want to Google. Here, let me go here. I'll go to Waterville Valley Academy. It's a very unique school. I'm surprised nobody has mentioned the World Cup today. It's a sports academy school. Whoops. Which means we are there because of the sports. Kids are tuitioned in because they have a care and a passion for snow sports. And so when they get there, here we go. And here's the peak program here. So anyway, they have a 7-day-a-week schedule of training, competition, and then we hopefully will get them in line with their curriculum at home. So I have 2 different sets of students. Students who come there for either 6 weeks to try it out or 5 weeks, and they are not in the peak program. I have sessions with them either 1 or 2-on-1. So the teacher population is very, very high compared to students. We have about a population of 80 students. And then in the peak program, they come and they want to experience this program. So, and it's been going on now for about 5 years. So, and
opportunity, Sally, you're so fortunate. That's really neat.
And did you say all those materials you're showing are available online somewhere?
Yes, if you have any questions, email me and I can get those, but they're in the folder that I created. I just downloaded them 2 days ago.
That's the Widgeo part that we were talking about, where we archive all of our pieces, and I can show you that after
cool.
This week when we if there's anything that you have to post there from tonight's meeting. So, and you can access all of that. Sally did a very thorough job of making sure everything was available.
There you go.
Thank you so much, Sally.
Okay, so now I do stop share.
Yep, you stop share, and then we'll all go back to there.
There you go. Hi.
I'm looking forward to looking at all of that again, Sally. That is, you really have a unique opportunity there. So great. Thank you for sharing what you do with us and your program. And I'm sure, Sally, you'd be glad to answer any other questions that anybody emails you or.
Anytime. I never understood a sports academic school, but they have them all over the country. Some are 12 months. It's not any different than a music school where they concentrate on music. So the core curriculum of the student is around their passion, and then they work everything around it. And it really is amazing. These are kids, some of them happen to be well off. That's not their fault. They're just ordinary kids. Some of them have scholarships to get there. It's a nonprofit school, so there's a lot of fundraising. And they're constantly working and training, and for some kids it's not a school for them because it is intense. I mean, on the weekends I see kids, they come back from training and then they're doing the wash for their clothes because they have to get packed up because they're going to travel. They're going to travel like to Colorado to train in the fall when there's real snow, or they do dry land training. So we have to be on the computers and communicating with them, and they have responsibility with their studies while they're away in training. So, and they know how to carry 5 or 6 pairs of skis on the plane. It's amazing to me.
Oh, how very unique. Well, thank you again, Sally, so much. It's always so fascinating to see all the different types of learning environments that you all are working in. Thanks again. All right. I would like to introduce our next presenter, and that's Paul Higgins, and he is a research fellow in solar physics at Trinity College Dublin. He does know our dear Claire, and he is currently a visiting researcher at Lockheed Martin Solar and Astrophysics Lab. His main research interests are in sunspot evolution and eruptions, as well as solar eruption prediction. Paul is a member of the Max Millennium Flare Forecasting Team. I want to say that again. Max Millennium Flare Forecasting Team. He is also lead scientist on the Sunspotters Zooniverse project, and he's directing the student to scientist program funded by the CS4HS grant to make science learning in Ireland more interactive. Can you tell us a little bit more about that, Paul? But please, Paul, take the stage. Welcome.
Okay. You want to know more about the Google project?
Is that what that is? I just said it was the CS4HS grants, and
yeah.
I don't know. I don't know what that is. Maybe somebody else does, but I don't.
Yeah, so it's one of the Google Foundation grants that they give out for science education and outreach, and this particular one is to get computer science into classrooms, basically. So we wanted to do a variation of just simple, computer science coding workshops. So we're combining CS with science, and we're using Scratch to make physics simulations, and we're doing teacher development workshops and student workshops in Dublin. So right now we're just about to run our first teacher workshop. At the end of the year, we'll be applying for more funding for next year to keep that going. And I'm also in the process of applying for funding here to start up an American version of the project. So you can check it. I'll post the website here. Students. There you go. Did you have any more other questions, or should I just get into the talk? Cool.
The stage is all yours, Paul. Absolutely. I just wasn't quite sure what that was, so thank you for explaining it to us. But yes, it's all yours.
All right. Full screen. Can you guys see the full screen page? Okay, it looks okay.
Yep.
All right, let me get the chat window out of the way. Okay. Yeah. So as Andy mentioned, I'm studying sunspots and how they evolve and what causes them to erupt. So Sunspotters is basically a citizen science project. It's just a research project for the research I'm working on, where we're trying to measure sunspot complexity. And I'll explain why that's important, why that's interesting, and why we want to do that. So the goal of this talk is really, I'm trying to inspire you guys, which I assume most of you are teachers at some level, inspire ideas or ways that Sunspotter can be used in your classrooms and maybe integrated into your curricula. So in this talk, I'll give a summary first of the science of Sunspotter. And I wasn't quite sure what level people were at with physics and whatnot. So I have some simplified slides and then some more technical slides to get both sides of people have a bit more knowledge about sunspots.
Oh, we have something, but everybody will be interested in all of that, Paul.
Great. So I'll talk about how the interface and how the project works behind the scenes. I'll talk about some results that we got from the last round of Sunspotters that finished up in March. And then I will talk about some of the activities that we've run with regards to education outreach, and show you some of the materials that are available right now. There's not a huge amount. And then talk about some future materials that might be useful for you guys. So what I'm really trying to figure out is what materials could we develop with you or with whoever that would actually be useful and that you guys would actually be interested in using in your classrooms. So first of all, just to give a very basic idea of what are sunspots. So if you look through a solar telescope that has a filter on the front, blocks out most light, you probably see an image similar to the top left corner. Let me see. Annotate. There we go. Spotlight. I assume you can see like a little laser beam type thing. So this is sort of a sunspot in visible light, and then we can actually take an image of the magnetic field distribution on the surface of the sun, so we can see where magnetic fields are coming out of sunspots, which are the black areas, and where magnetic fields are going into sunspots. Sorry, into sunspots is the black areas, and out of the sunspots is the white areas. So you can see this is a pretty complicated sunspot where there's really a mix of magnetic fields going in and out. If we take an image of the atmosphere of the sun, you can see that the magnetic fields permeate into the solar atmosphere, and the hot ionized plasma in the solar atmosphere gets tied to the magnetic field lines in three-dimensional space. So we can take the extreme ultraviolet image, which is this one, and it's really a map of the 3D magnetic field of above sunspots in the solar atmosphere. So to demonstrate this, which I did to a bunch of students last Friday when we relaunched Sunspotter, I got a bottle of baby oil, put some iron filings in it, and used a magnet, and I was able to show sort of generally what the magnetic field looks like for a single sunspot, where it's just magnetic field coming out and it looks sort of basically like a circle. Or if you put the magnetic field, if you put the magnet against, like lay it flat against the bottle, you see sort of a dipolar, we call it a dipolar structure, where you see two sunspots and sort of loops connecting in between. So they seem to have fun with that, and maybe give them a bit of a more physical picture of what sunspot magnetic fields look like. Let's see. So, sorry, one sec. Scientifically, what we really want to do is obtain a quantitative measure of complexity for sunspot group magnetic fields. So we're trying to answer two different things scientifically. One is, do more complex sunspot groups produce more eruptions like solar flares and coronal mass ejections? Also, can an accurate knowledge of complexity, sunspot group complexity, improve the forecast that we give for eruptions? So as Andy mentioned, I'm a forecaster, a space weather forecaster, and we really go on intuition a lot, but we want a more numerical, automated method of forecasting. And at the moment, most methods are pretty unreliable, so hopefully better quantitative knowledge of complexity could improve these forecasts. Lastly, we want to figure out if sunspot groups are born complex or do they evolve to become complex. And this is a part of the project that's just been launched last Friday. So the first part that I talked about, phase one, we've completed the data, if you want to call it the data acquisition phase, or people have basically gone on the website and ranked all the sunspot groups. And I'll talk about how they actually did that. Okay. As a space weather forecaster, if you want to call me that, basically we look at data, look at real-time data, we look at what sunspot groups look like right now on the sun when we make our forecast. And we look for certain patterns that tell us semi-intuitively whether the sunspot group will erupt or not. So here you can see on March 28th, I saw this interesting looking sunspot group that looked like this. And then on the next day, let me get my spotlight. This is what it looked like the first day, and on the next day it looked like this. So you could see there's some stretching going out on along the top of the sunspot group. And then when you look at the magnetic fields, it looks like the line separating the white and black areas got a lot stronger and more stretched out. And then if this movie was working, which it's not, you would see an eruption happened actually the next day. So we successfully predicted that based on the patterns that we see visually. And of course, one of the patterns we look for is how complex the sunspot groups are. So as simple as I can put it, what we know in solar physics is that small, simple sunspot groups produce small eruptions, and much bigger and more complex sunspot groups produce much bigger eruptions. So if we get a bit more technical, there are a bunch of different ways of actually, I guess, quantifying complexity, but it's not really true complexity. It's sort of a numerical method that someone's developed to get, an estimation of complexity. But it turns out these proxies for complexity don't do that well and are really hard to physically interpret. So the most, or the I guess, proxy for complexity that's done the best so far is this thing called the expert classification, which is, it's called the Hale classification in this case, where people classify sunspot groups using a couple different schemes. So an alpha sunspot group is one that's just a single sunspot, so either just white or just black magnetic fields. A beta has both white and black, and then there's, you can see in this list here, there's gamma, delta, beta, gamma, delta, and those are just more complex, mixed up classifications. So there's a group of Air Force guys that are trained, and they go on every day look at what's on the sun, and they basically put out a list of classifications of the sunspot groups that are there. And people have done analysis on all these sunspot group classifications that these Air Force guys have done. And you can see that from this plot here, more complex stuff, which are these red dots here, produce much bigger eruptions, which is this line on the y-axis. Also, much larger sunspot groups produce bigger eruptions, whereas the more simple ones, the alphas and the betas, produce much smaller eruptions. So that's sort of like this is sort of the main work that people base all of their complexity stuff on. And we're trying to take this further and actually make a more continuous measure of complexity rather than just having a few classes of complexity. So I was trying to explain, yeah.
This is Nancy. I'm going to interrupt you just for a moment. We've got a couple of questions on the chat, and I'm wondering if you'd like to take questions as you go along or wait for the end.
Absolutely, yeah. No, sorry, I should have mentioned that. Please interrupt me at any time. I was trying to make this more conversational. Let me see what we have here.
So I think a little ways back, Vic had asked what frequency is used to see the magnetic fields.
Oh, okay, right. That's a really good question. So these magnetic field images are actually, we actually need to take something called filtergrams, which is an image at a very specific frequency. And we take about, I think in this case, there's 5 different filtergrams that are used to make a single magnetic field image. And each filtergram is at a different place along a spectral line, which is very affected by the magnetic field. So with stronger magnetic fields, this spectral line moves around due to the Zeeman effect. So we take images at different points along the spectral line, and then we use something called an inversion method to get from spectral line images to a magnetic field image. I hope that answers that question. So these are, yeah, so the images that I've showed so far are with HMI, but for phase 1, we've actually used images from the magnetic, what's it called? The Michelson Doppler imager, which is from SOHO and actually has a much poorer resolution than HMI, and the images aren't as pretty. But we will be switching to HMI probably in a number of months for the 3rd phase of the project. Any other questions?
There was a question about HMI, what it stands for, which I believe is helioseismic and magnetic imager. But I'm wondering if you wanted to say anything more about that.
Yeah, so HMI and MDI, so HMI is this newer instrument that's on the Solar Dynamics Observatory, SDO. And it has a really good resolution spatially and temporally, meaning like you get a lot of images per minute with really high spatial resolutions. You can see really detailed magnetic field structures on the sun. MDI has a sort of a 96-minute cadence, and the spatial resolution is about 4 times worse. But overall, the instruments are pretty much the same in that they use these filtergrams to take pictures along a spectral line and then go from that to magnetic fields. So they work pretty much the same. HMI is on the Solar Dynamics Observatory, and MDI, which is the one we use for phase 1 of this project, is on the SOHO spacecraft. So I gave part of this talk to a group of sort of 6-year-olds to 12-year-olds, and this is one of the images that I have shown here, where I was trying to explain what complexity actually means. And the simplest definition I could find was having a lot of different parts in a really intricate arrangement. Something that I thought they might have some context for was comparing an old-fashioned phone to a smartphone. Let's see. Does it image the plasma in the field, or can it determine the field itself? Can you explain that question a bit more, Vic?
I'm still way back at the beginning, trying to determine how you can get a photograph of a magnetic field.
Oh.
And that still doesn't sink in. And so I'm trying to figure out, well, if it's you're actually detecting the plasma in the field, or can you detect the field itself?
Right. Okay. So here, what I've drawn, hopefully you can see that image I'm drawing right here.
Yes, I can see it.
Yeah, so this is a spectrum, right? Lambda means the wavelength of the light, and the I is the intensity of the light. So if we had a spectrograph, we could see, you know, a spectral line, and if we aimed the spectrograph at the sun, you know, we might see different spectral lines on the sun. And if we zoomed in on one particular spectral line, we would see that. Now, we can tune our imager to just take an image at one particular frequency. Let's say this one here. So we get an image, and basically the intensity of the image is just given by the intensity that you get from that part of the spectral line where I've drawn that line right there. So we'll get an image. Sorry,
so the brightness of that frequency.
Yeah, exactly. The brightness at that particular frequency. So we get an image of the sun. Let's pretend that's the sun because it's hard to draw with my finger pad. At one wavelength, and then we get another one at another wavelength. Let's draw two there. And that might be, let's say, in the core of the line right here. And then a third one over here, let's say. And then we basically combine all of these images by subtracting subtracting the images from the different parts of the spectral line. And there's a particular equation that gives you what the magnetic field is based on the difference between the intensities of those different parts of the spectral line. So the Zeeman effect basically causes this spectral line to move this way or this way. If the magnetic field is pretty weak, the spectral line moves a little bit. If the spectral line is, if the magnetic field is really strong, you actually get a splitting of the line that looks something like that. So you'll get actually a line core there and a line core there. And the difference in spectral distance between those two line cores of the split spectral line is directly related to the magnetic field. So does that help a bit?
Yeah, and does it give you, then where do you get the direction, whether it's coming in or going out?
Oh, right. So whether it's coming in or going out, basically I'll call it delta 1 and delta 2. Let's say those the subtraction of those give you the magnetic field. Whether that number is positive or negative will tell you which direction the magnetic field is going. And this is just to measure the magnetic field in the line of sight, whether it's coming out or going in. That was a really simplistic and sort of misleading answer because we actually take filtergrams along the spectral line like this, but we also polarize. We take filtergrams with polarized light. So we use a polarizer to just take, you know, right circularly polarized right circularly polarized light and left circularly polarized light. So it's actually a bit more complicated than that, but that's sort of as simple as I could explain it without some more plots, I think.
That's a start. Thank you.
Okay, no problem. Let's see, how do I erase this now? Okay, let's go on to the next slide then. Yeah, please stop me at any point if anyone's feeling lost. So this slide, I was basically trying to show that you know, there's a range of complexity of sunspot groups. The most simple ones either just have white or just have black, or have maybe white and black, and you can draw a pretty, you can sort of draw a line right down the middle. And that's a pretty simple configuration of sunspot group magnetic fields. As you start to mix around the white and the black, you get something more like the middle image. However, if you keep mixing around the magnetic fields until you just have noise or speckles of white and black everywhere, you get sort of the third one, and it becomes simple again. So what I was trying to get at is there's this sweet spot of where the complexity lies between just a simple configuration and noise. And that's what we're trying to determine with Sunspotter. And computers have a really hard time of doing that, but people can pretty easily say that the middle image is the most complex. So I tried to do an analogy with Legos, where if you have all the Legos of different colors separated into little places, it's pretty simple. Or if you just have a big mess, it's sort of simple to just say it's a mess. But in the middle, you can build some pretty interesting structures with the Legos, and that's sort of the complex thing that we're trying to get at.
Okay, I'm going to ask another question right now.
Go for it.
On your website, you have this setup where you can choose complex and simple.
Yeah.
Okay, so that I understood, but is there a place that you can check yourself on, are you identifying these appropriately?
Oh,
kind of a self-check so that you know, kind of self-train that, okay, this is what simple looks like, this is what complex is. And you can go through it, and then is there some way to check it and say, yeah, you got most of them right, or boy, you don't have a clue?
That's an interesting point, yeah, and that's not something that's really built into the website. What we did do was we have sort of, not really a tutorial, but sort of like an explanation of what we mean by complexity. And there's a link at the top of the website. If you click, I think it's science, maybe. Or I think it just comes up as what do we mean by complex if you click on that on sunspotters.org. And that gives you some examples of what, what's comparing two different images, and then we tell you which one we think is more complex. So it sort of gives you an idea of what we mean. But in the end, no, we can't really do that because we don't really, I mean, this data set has not been classified in terms of complexity, so we don't really have anything to match it against. Once you've classified an image, you can then click on that image and look at some metadata associated with it. So you could see, did the Air Force classify that image as an alpha or a beta gamma delta? So if you're classifying a bunch of alphas as more complex than a bunch of beta gamma deltas, then you're probably doing it wrong.
Okay, I missed the piece on how to check it. So if there's a check, okay, I'm happy.
Okay, yeah. Yeah, so this is just an example that I showed to a bunch of kids, and they all unanimously pointed to the B as being the more complex one. And I've done this test to groups of scientists, groups of general public, and everybody seems to have a real intuition for which one is more complex. So I've trusted the crowd overall. In this case, there's a movie that would have played if I'd compiled my thing correctly, that you would see an eruption actually happen in B, whereas nothing really happens much in A. So that shows that complex sunspots often have a lot more going on in the atmosphere above the sun. This is an image in 304 angstroms, which is extreme ultraviolet. So you're seeing just above the atmosphere, just above the sunspot in the solar atmosphere. So
I'm going to interrupt one more time. Is this the technique then? For example, if you go to spaceweather.com, they start giving you percentages of chances of various types of eruptions. Is this the concept that they're using? Are they taking your data or what on how they can predict, well, there's going to be a 50% chance of an eruption or a 10% chance or no percent chance?
Right, so I'm trying to think of what spaceweather.com does. I believe they use an algorithm that looks at classifications of sunspots. So it's a different classification scheme than this alpha, beta, gamma thing I'm talking about. They use, I think, Macintosh classification, which doesn't look at the magnetic fields of sunspots. It looks at just what the sunspots look like in white light and visible light. And these Air Force guys classify them in terms of their visible light configuration. And basically, the spaceweather.com looks at historically of each classification how many eruptions were produced by sunspots of that classification. So assuming that there's a certain rate of eruptions for each sunspot classification, when a new sunspot comes up, there's you can get a probability from that historical data. But that's quite separate from what I'm doing here. Yeah.
So you're basically on an edge of a new systematic way of predictions.
Yes. Yeah. Exactly. Yeah, and that's sort of our science goal, is using complexity from Sunspotter to do these predictions, as opposed to using some of these Air Force things or other measures that have been used before. That's right. So this slide is just showing where we are right now in the project. We've just headed into phase 2. In phase 1, we had about 13,000 images. In this case, we have 200,000 images. At the moment, as you may have heard through the grapevine, that there's now 1 million Zooniverse volunteers. So it's actually feasible to do this scale of study, because we actually need millions of clicks or millions of classifications of sunspot complexity to get through the whole data set. So I just wanted to talk a little bit about the results, some of the results that we've gotten from the first data set. If you have any questions, let me know. It gets a little bit technical here, I think. So as I mentioned, we started with 13,000 sunspot group detections, and basically in about a month, I think 30 days, almost exactly, 1,600 volunteers had gone through the whole data set and done around 300,000 classifications. The images that we showed were 2 scales, so 2 different sunspots, no matter if one was really small and one was really big, they would see it like that. They wouldn't. We weren't just cutting a square around each one and then rescaling it. So people for space in the images. Once we got comparisons of a ton of different pairs of sunspot groups, we used something called the ELO ranking algorithm to go from a list of classifications to an actual list of sunspot groups ranked in order of complexity. So that's where we go from. So using that, we can actually get some science out of it. And the ELO has been used a bunch of times. For instance, it's used to rank chess masters. And the basic way it works is that it seeds every image or chess master or whatever you're trying to rank with some initial score, and then as 2 different things are compared, the difference in between their scores dictates what happens when one or the other loses. So with 2 sunspot groups, if one was initially classed as really complex and the other was classed as really simple, and then someone shows that the simple one was more complex than the one that the algorithm thought was complex, the score for the simple one would shoot up high. So basically, ELO is a way of getting the scores to converge on their quote-unquote true score more quickly than using some other algorithms. So as far as results are concerned, sort of the simplest result that we can talk about is which images do people class as the least complex and which do they class as the most complex. So in the top row is showing the least complex images. And as you can see, there's not really much stuff going on, or if there is, it's sort of just a bit of white or a bit of black or nothing there at all. Whereas on the bottom row, you can see really complex, really strong magnetic fields. So that gives us some faith that people at least classify things pretty overall correctly. Likewise, I've shown here the A, B, tells you whether it was alpha, beta, beta. So that means that's pretty simple stuff. On the bottom row, you can see that the Air Force class stuff is unknown, beta, gamma, delta, beta. So what I'm showing here is that sometimes their Air Force scores kind of break down. Sometimes they don't actually classify something as here it's unknown, or sometimes there's 2 sunspot groups really close together and they class each one a beta, but in our case, we're calling it the same group, so it's actually a more complex thing. So I think there's a more useful way of in the end, we ended up with a more useful way of measuring complexity, at least as far as forecasting is concerned.
Well, there was
so
a comment in the chat, or a question in the chat.
Yep.
About how do you decide which time periods and areas sunspots to analyze with volunteers, and what is the amount of time it takes to conduct these?
Right. So for our initial data set, we chose a data set that's actually been used in other studies so that we could compare our results with those studies. And that time period is most of solar cycle 23, which is a solar cycle that just happened. So that's from 2000 to 2005, 2006. So those 13 images would have been spaced over that amount of time. What is the amount of time? What do you mean by what is the amount of time it takes to conduct these?
How long of the time frame does it take for people to count this up? I mean, what amount of time to get volunteers?
Oh, well, it took a month to classify everything. Is that what you mean? Each classification, I think people do in like a few seconds.
So just a few seconds for classification is what you're saying, Paul, before it goes on to the
okay. Yeah, sorry, I didn't quite understand. Yeah, people don't spend long on each one. That's for sure. So in this plot, I'm comparing alpha, beta, and gamma, delta classifications, which are those Air Force classifications, just so we can have sort of a benchmark to compare our stuff against. And the ELO score is basically the ranking of how complex each of our sunspot groups are. This is a histogram, so the y-axis is the number of sunspot groups for each ELO score bin. And so the red histogram is the Air Force says are the least complex sunspot groups, the alpha class ones. And you can see that distribution peaks at lower ELO scores than, say, the beta class sunspot groups, which peak a bit higher, and then sort of gammas and deltas peak even higher than that. What we really want to, so it shows that as those classifications that we would consider to be complex in that order from beta to gamma delta matches what we find in our complexity scores that our volunteers have given us. So that's a good sign. But what we really want to do is to go from ELO score to a number that's a bit more useful. So I came up with sort of a complexity score that just goes from 0 to 100 and sort of scales things a bit differently. So what we're really interested in these most complex, let's see here, this bump in the distribution over here is the most complex sunspot groups, and that's the stuff that we're really interested in because those are the ones that produce the eruptions. Andy, can you let me know how much time we have left?
It's 7 o'clock right now, so you have about 15, 20 minutes.
Okay, perfect. So in this plot, I've rescaled those distributions so that we take all the alphas and betas, all the least complex stuff, and smoosh it down to the bottom, the low complexity, and then we spread out the more complex stuff, so we get a better, what you might call dynamic range. And then this gray line is basically the distribution of sunspot groups that produce large eruptions. So you can see all the sunspot groups producing large eruptions are at the higher complexity higher complexity scale, which is what we expect. And that's sort of our main science result at this point, and sort of proves what we were hoping would be the case. So in this plot, we are taking complexity scale and we want to compare it to different physical properties, more properties that make more sense, like how much magnetic flux is there in a sunspot group or the area of a sunspot group. So in this plot, it's complexity versus magnetic flux. So this is just trying to show that, you know, if you're trying to explain this stuff in a classroom, you could compare complexity to different physical properties that you could actually talk about, or if you're talking about, you know, magnetism or so forth, this might be interesting for them. So now I want to talk about a few of the outreach activities that we've run over the past year or two. One thing we did was a live, before we actually started the Sunspotter project, before it actually went live on the website, we did a test of Sunspotter classification rankings with a group of 15-year-olds in the Science Gallery, which is in Dublin, Ireland. So we had about 20 students, and we had about 15 different images of sunspot groups. And then we paired them up in like 100 different ways. And then we just showed the students the images one by one, and they picked which one they thought was more complex. So that gave us a really big data set of all these different students doing that. We also did the same thing with scientists in Finland. And it turned out the scientists had a much harder time with the project because they really wanted to know what we meant by complexity, and they got into all these details that the students were just kind of ready to go, and they just did it. So that was interesting to see. We found out with this way of doing it anyway, it's really labor intensive if you actually want to analyze all that data, because you get 20 different sheets of 100 different pieces of data each, and then you have to put those into a computer and analyze them. So we need to think of a better way of doing that can sort of expedite the process. So we've just launched phase 2 of Sunspotter. We also did a launch in Dublin for the phase 1, which happened in February. And basically for both launches, we had a bunch of those students, and we gave a talk about explaining solar activity, another talk explaining citizen science and how people can get involved with science, even if they don't really know much about science. And lastly, a quick talk about the Sunspotter project. And then in both cases, we passed around iPads and had the students actually try out Sunspotter. And what I found, I did something like this with a group of very young students. I think they're about between 6 and 12. And the youngest students kind of didn't really get, I guess, the project. Looking at sunspots, it wasn't super engaging for them. So there are actually other Zooniverse projects that I was able to have them try, like one called Snapshot Serengeti, where they can go on and classify animals that are
Do not tell the teachers about that, Paul. They will never get off of there ever.
It is a really addicting
Adler, obsessed.
Yeah. It turns out people really like to look at basically we sent a PhD student around to a bunch of different high schools and had him give a talk about the sun-earth connection, solar activity, and then ran a workshop where the students actually classified sunspots in terms of this Hale classification I was talking about. So they told us whether it was alpha, beta, beta gamma, and then we had an explanation of each classification, so they could do that. And then they were able to actually recreate that plot that I showed in the beginning. This one here, which is a professional scientist plot, and they were able to make their own plot, this one here, and compare to it and show that they could actually do something comparable to professional research and intercompare the results. And there is a full description of this project online down here, so you can check that out later if you want. Also I wanted to talk about, we do have some educational resources available on our Sunspotter website. We have links to some videos, NASA videos, and videos of our guys talking about the project. We have some PowerPoint slides from some of these talks that we gave to students and the public. And we also have that activity description that I just talked about in the last slide. So you can check out this stuff on ZooTeach. Another thing we have on the Sunspotter website is Talk, and I think all Zooniverse projects have a version of this. So after someone classifies some sunspots, they can then go on and discuss the sunspot images, or just present, just give a random discussion or something they're interested in, or some question they have about the data, all kinds of stuff like that. And myself and some of the other scientists actually go on to talk and interact with people. So it might be fun for students to go on and actually ask some questions to scientists running this project, if they're, if it's being used in their classroom.
And I think almost all of if you use other Zooniverse projects, all of them do have that feature in that talk. So if some of you are familiar with Galaxy Zoo and Hanny's Vertorp, that's how that was identified, was through this talk feature. So it's really in all of, I know for Sunspotters for sure, the talk part of it is actually archived. So your students can go back, if they have questions, they can go back and see some of the other conversations with scientists as well.
Yeah, that's right. So then I just wanted to talk about, I think it's my last slide, some future resources that we'd like to develop. So I'm not sure, it's not clear to me whether the resources I've showed so far would be useful in the classroom. So I wanted to get some feedback from you guys on that. But one thing we are interested in adapting to Sunspotter is something called the Data Navigator, which would allow people to go on, have a classroom, go onto Sunspotter, and make a group on Navigator. So then they'd be able to classify a subset of the sunspot groups as a class altogether, and then they could see the ranking that they came up with as a group. Afterward, they could then make graphs or plots of the different physical properties of the sunspot groups that they classified. So they could plot the total area of the sunspot groups versus the total magnetic flux, or against complexity, and then determine whether different populations produce flares or not, so they can see what sorts of sunspot group properties lead to eruptions or flaring.
Paul,
this is
Andy. Now, explain. Will you talk a little bit about the Navigator piece, because this is a selected set of data, right? That is meant to.
Yeah.
Can you talk about that a little bit? Because many of the other, I've worked with Planet Hunters, and we do the same thing with Planet Hunters. Is so that you have an opportunity to use the actual data that is selected, and you don't have the chance piece. Can you talk about that a little bit?
Yeah. So I mean, as an example, this works for Galaxy Zoo. What you could do is take 100 different galaxies as a subset, and then in your classroom you could say, okay, you could pass out iPads and have everyone go onto this Navigator web page, and then pick your class as your group, and then for those 100 galaxies, you could all as a group classify those galaxies, as spiral, elliptical, or whatever the other Galaxy Zoo classifications are. So that data set would be yours, sort of, for your classroom, and no other volunteers around the world or anybody else would be involved in that. It would just be your class. So on the back end, that after you've classified everything, that would sort of give you, a classified set of data that you could then analyze as a classroom. And by analyze, I mean you could make, look at the total set of data altogether, all the images. You could make histograms and say, okay, how many different galaxies had this classification, how many had this classification, or also you could make scatter graphs where you could plot the different properties against each other, like I was talking about. I think in the case of Galaxy Zoo, you could plot the color of the galaxy versus the size of the galaxy, or the how old the galaxy is. Look at galaxy evolution that way. So likewise, you could do similar things with Sunspotter. So if anyone has any questions, or you want me to explain anything else more in depth, let me know.
No, I just so the teachers understood that they had their own data set and could actually be using real data. So that is theirs, that they could then manipulate in different ways. Not manipulate, but categorize and analyze in different ways. That was all.
Yeah. So that's pretty much all I have. And basically, I just wanted to get feedback from all of you. If you think a Navigator for Sunspotters would be something you'd be interested in using in your classrooms, or how you might, if you have any ideas about how you might tie Sunspotter to your curriculums, or some of the other examples I showed, whether you could use those in your classrooms.
Diane, you put that your astronomy students would be doing this, certainly be doing this next year. How do you see yourself using that with your astronomy students? Can you hear me, Diane, or? Oh. Sunspot. So how specifically do you think that you would use the Sunspotters one?
Well, as we go through the different units, anytime I can put the kids in front of a computer and say, go to this website and do this, it just gives so much more meaning and so much more power to everything. That it just, it's authentic. It's data they can work with, and that's the power of this.
So what do you think you would use it in conjunction? What do you think that you would, how would you pair this up? Is it just something you would randomly say here? You know, like Laura pointed out that she uses Serengeti as a reward, which I'm serious, don't go there. You guys will just have a on Facebook. But you know, as a reward, because but do you see it as, how would you use it contextually in your classroom? I know I'm putting you on the spot, Diane.
Well, no, I actually have a lab where they are ratty old black and white photographs that could have been taken by Edwin Hubble himself, and they are all the different things, and it's like, how would you classify these? And so they, you know, we spend a little bit of time, and some of them try to do an evolutionary sequence, and some of them just do spirals and ellipticals and the irregulars. And so, I mean, that's been a lab forever. But for me to be able to put them in front of a screen and have them work with real images of galaxies that are out there, just, that's breathtaking.
Okay. So would you, I guess, would some of you be then interested in, you know, having some discussions later on and talking about specifically how we would implement some of this and make an interface like Navigator?
Yeah.
Well, my 2 cents on this one, I do a unit on space weather, and with that, we normally end up and said, okay, the sun just had an eruption, we got a coronal mass ejection, and here it comes. I have never been, okay, where does that come from? How do you know how can we predict, using data, can we predict that's going to happen? And so I can see it as a lead in to my unit on space weather. Because then they can start looking at the complexity of these various sunspots and say, okay, if you see one like this, that might be worth watching. See one like that? Nah, don't worry about it. It would give them authentic data to look and be able to predict.
And Paul, this is Ricky from Space Science Lab. Do you guys, could you interface it with the J Helio viewer so they could make predictions and then use the J Helio viewer to see if that was actually what happened on the day that they predicted it?
On the day they predicted it, they could use some of the NOAA data, because J Helio viewer I don't think is quite up to date enough. So like if you're looking for data from today, I could send you a movie. There's a movie that's updated every day, and it shows you what flares have happened. And you basically just see flares going off like up to the last, I think, half hour, up to the last hour of time. So I'll send that around, actually.
Yeah. Well,
that would be great if you could predict it, but I don't think it's really that necessary, as long as the students can see a cause and effect. That, okay, here's a sunspot. This is how it developed. We considered it complex, and then we have proof that it erupted. Or we decided this sunspot was an alpha and it went away. Nothing happened. You know, even if
Right.
it happened 3 years in the past, it gives us the ability to look, to predict, and get results.
Oh, okay. Well, actually, for that, I would probably use solarmonitor.org because you can click back in time and you can click by solar rotation or by day. And then you can see what sunspots were on the sun. And then below, at the bottom of the page, it shows which of those sunspot groups produce flares and how big those flares were.
Yeah. And I think being able to visualize the data that they're collecting is really powerful for students.
Okay.
I would
Oh, and
think,
somebody else. Sorry, go ahead.
I was just going to say, to me, this takes the sunspots out of the abstract. It seems to me, you know, when you talk about sunspot, or when I shouldn't, you know, and I haven't worked with heliophysics with students for a number of years, but you know, it takes it out of a quality of the sun into something that is an entity of its own and has its own uniqueness about it. You know, it's not just a freckle on the sun, I guess is how I had one student talk about it, but this now you can look and see how this is not only a quality of the sun, but also its own dynamic piece that has cause and effect, I guess. I think that's really interesting about this project.
Okay. So it sounds like most people are interested in, or it'd be really good if we could know which ones actually produce flares. And actually, back to this talk.sunspotter.org, one of the metadata pieces that we have after you classify a sunspot group is it tells you whether it produced a major or a small flare in the next 12 or 24 hours. So that might be useful. It says
when you're working with kids,
yeah.
When
Sorry, go ahead.
when you're working with kids, you almost always have to end up with an end product. In other words, if they're working on something, they don't see an end product, they'll lose interest real quick. But if they see, hey, this is what happened, it could happen 2 months ago, and they'll still be excited that they got a chance to see it happen and to be able to make a prediction. But to not have an end product, I think it would get, I don't think it would last long.
Okay.
What are the curricula tie-ins that you all see? Again, you know, it's been so long since I've, you know, my work with in a classroom with heliophysics has been a few years ago. But what do you see as it fitting into what curricula you already use in your classroom? How could this enhance it or be an add-on for you?
Well, I just went on Zooniverse and I really like it. I'm actually this week writing a curriculum with the 8th grade math teacher, and we're focusing on some of the Texas TEKs, and I know also the national science standard talks about the different components of the universe. So this is a really great website that I can incorporate into writing my curriculum tomorrow. So this is great timing, and anytime that a student gets on the computer and uses technology, administrators like that, and students love getting on the computer, and this is a great website, I think, that I can actually incorporate into my new lesson. So thank you for sharing that.
Great. Somebody was saying I do need a review of the HelioViewer, Sally Jean. Do you want me to explain what HelioViewer is, or?
Claire actually did, as part of our virtual retreat last year, she did a breakout session on HelioViewer and HelioJViewer. And so I think that's what Sally was referring to, is going back and using, looking at the platforms again, which we all do need. So because we were all fascinated with it as well. But any other curricular tie-ins that you guys see, or what you already teach in your class, how this might tie in with what you already do as far as helioscience and sunspots?
Well, it's not, for me, it's not so much tying it in with the heliosciences, but bringing it in, because where we are with middle school in Texas, our TEKs aren't specific to heliosciences. So some of them are, but not as much as we would like. But what we would do, or what I would do, is certainly pull this, and as I put in the group chat earlier, pull this and use it during our Nature of Science unit, which is a 3-week unit that we always have at the very beginning of the school year. And so what you're doing is you're learning during that 3 weeks, the children are learning how to think like a scientist, and how to question like a scientist, and how to use the tools that a scientist uses. And that incorporates basically 4 very specific standards for the state of Texas. And this would be fantastic for that, something new and different. And Molly, when you're writing curriculum tomorrow, think about putting it in there as well, because it's a really good spot for all of this as well. You know, and again, everything is just sort of clumped differently, but you can certainly justify using this, because we are asked to have students use real-time data. And this is perfect for that. So thank you again.
Well, and not to forget that these projects are, you know, especially so when your students use Sunspotters, they're helping Paul. You now have a face to put that in there, that they are doing work for him, so that they are analyzing data for him, so that he can actually use that very, very quickly. Stuart, so anybody who wants to make a field trip to the Adler, the Zooniverse is, part of it is housed at the Adler. And Stuart Lynn, one of the project leaders, has a lovely thing that I'll share at another time about how this analysis really does allow scientists like Paul to do their work very, very quickly and see results very, very quickly. And so, you know, I think that's an important piece, is that you now have a face to say you are helping this man do his research and be able to do really amazing things by doing that. You're all invited to the Adler all the time, so please know. I have a 1-bedroom apartment, but I have lots of floor space. So good. Any last questions for we? I do want to be respectful of our time at 7:24, so we have about 6 minutes left. But any last questions for Paul? Or yes, that they are helping with current research. It is so important that the students understand that this is real. It's not a game. It's not a video game. It's real. And Paul, I'm sure, is grateful that they're helping. But any last questions for him?
Great, thanks a lot.
So Paul, you're using Sun Cycle 23. What about Sun Cycle 24?
Yeah, I should have mentioned. So for phase 3 of Sunspotters, we're going to transition from MDI to HMI data. So the resolution will be a lot better, as I mentioned before. And the data will take us up into the current state of the sun. So we have about, it's 2014 now, so about 3-4 years of data from HMI for people to classify. And once they get through all that, then they're classifying real-time data. And presumably we'll be able to create a flare forecasting algorithm based on sunspot complexity. So it's conceivable that people could actually be doing complexity classifications that are fed into this flare forecasting algorithm, and we could actually, make, a percentage of, is this particular sunspot group on the sun going to flare, 15%, 20%, whatever it is, and that'll be based on people's classifications in real time.
Well, thank you so much, Paul. I'm going to email you tomorrow, and we can talk about how to get you on the Wigio and post this amazing work that you've done and your slideshow, if you'd be willing to share it with us. I know that teachers do go back, even though we record things, these teachers do go back and look at these slideshows and figure out how to use them in your Nancy, it is a public thing, so anybody can use it. Oh, wonderful, Vic. I'm glad you can use it in your class. I will post some things on the Wigio tomorrow about Zooniverse itself. I am a little biased about it because it is at my institution, and I work with these incredible people that help make this thing real. So anyhow, but Paul, we'll talk about how to get your stuff on there, and I know that teachers will have questions for you. So as they digest all this amazingness that you've just shared with us. So thank you for taking the time, and we hope that you'll kind of lurk in our community a little bit so that we can continue to ask you questions and involve you in this work.
Yeah, absolutely. Thanks for having me.
Anytime. We're so glad that any friend of Claire's, man, any friend of Claire's. So we are almost at our time. We have 3 minutes left, and I want to be really respectful. Normally, we meet at the third Tuesday of every month, Paul, and so every month we do this. However, we had you take a short survey about how we wanted to proceed about summer, and it came out of that survey. It came to light for us that the Maven professional development time was over the third week of July. And so plus people were posting their summer plans. It seems that everybody has a really, really full July. And so it was one idea that in the coordinators meeting that we had wondered if perhaps postponing or just choosing not to meet in July would be better for everyone, since it's such a small group of us, and we know that you all are loath to miss what we talk about. We know that you love what we do very much, and so that is one thing that we have suggested. And if you have strong feelings one way or another, now's the time to voice them. Otherwise, we are looking at maybe taking a break for July so that you can all enjoy your summer activities with all of the busyness, even though it's hard to think of not seeing all of your lovely faces the third Tuesday of the month. But that is what we're thinking right now, just based on the data from the survey that you all put in. Any thoughts about that? Initially, it's not definitely there's places for you to chime in and vote your piece, but any initial thoughts about that for anyone? No, crickets. Summer is so hard, isn't it? And not only that, but well, Vic, that is one that we had looked at postponing July for sure, and perhaps even August, that maybe we would meet back again in September. We're going to look at the data again and determine about August. But people are just so busy, and so much with all of you going back to school. Somebody posted that they go back the second week of August. I thought, oh my goodness, you have such a short summer. So it is hard. So yeah, it's a little hard to give it up because I know I look forward to it every month. And I know you all do too, but we're all so busy. So right now we're looking at July and perhaps even August, and then coming back strong in September. So, oh, it's you, Nancy, that went back the second week of August. God bless you. Anyhow, so unless there is any strong feelings about yes, and of course we could all just decide to get together informally if there's those of you who want to get together and just chat and meet up and smile at each other and share about summer. We can definitely arrange that as well. But for right now, I think we'll let you have a reprieve for July so that all of you Mavenites can go Maven and come back and share all your excitingness. I know Lynn's like, yeah. Yes. It's an exciting time, and Molly has such a full summer as well with all of her curriculum pieces. And so I think that we'll have a lot to share in August, September when we can meet next. So we'll keep you posted. However, I am going to be poking you all in the Wigio and have you share, and maybe we can do some asynchronous sharing, looking at updating some resources that we've shared in the past and getting your input on those so that we aren't so far away from one another and can help each other get prepared for the next school year, which I can't even believe I'm saying since you all just ended your school years. But I know, it just goes so fast, so much. So yes, Paul, thank you so very, very much. Thank you, Sally, for sharing the rest of your amazing program. Thank you, Paul, for taking time out of your busy schedule to come share this amazing platform. I can tell how excited these teachers are about getting their hot little fingertips on this. And I'm guessing you'll see your data numbers go up quite strongly when school is back in session. And so we appreciate you taking time to do this. Yeah. Anyway. Yes, these are good. This is the group you wanted to be in, Paul. If you want input, this is the group that will give you input. So um, they will be glad to share all of the thoughts and ideas with you. So yeah, so Sally, if you want to post more on the Peak program on the Widgeo, or actually for those of us, I think we'll say goodbye if those of you need to go. Otherwise, Sally, there's some questions about your Peak program. We can hang on for a little bit longer. I know, Ricky, I don't know what your next piece is that you need to do, or if you want to pass me the host button, I can sit here while people chat if you need to move on. But thank you everyone for coming.
Thank you.
We hope you have a lovely, lovely summer.
And I'll post my PowerPoint at some point. I don't think it's too big, but anyway. All right.
No, I don't. And Sally, if you have a problem, let me know. We can figure out how to
sure.
compress it. If not, I will. I know.
And my laptop doesn't freeze, so I'm so excited now that I'm going to my big laptop. I'm still on, Windows 7. I'm sorry I'm not on 8, but that's okay. It still works.
It was great to have you smiling at us the whole time, Sally. No, Vic, there's no shrinking violets in this group for sure. All right. Well, thank you, everyone. We hope you have a lovely, lovely summer, and enjoy yourselves. And we'll look forward to all of these wonderful reports back from your exciting summers.
Thank you. We'll
Bye,
report
everyone.
Bye. And Andy, I can stay on for a bit.
Okay. I'll hang out here with you, Ricky, if there's other people who want to ask Sally their questions. And Nancy, you are not shy and reserved at all.
Oh, yeah, I am. Yeah, try.
I'm going to say goodnight, everybody. I'll talk to you soon. Bye.
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 Well, y'all have a really good solstice.
Yes.
Coming up on Saturday. It's going to be fun.
The longest day of the year. Hooray. I'm glad you brought that up, Nancy. The longest day of the year for sure. Yeah.
Yeah. Looking forward to it. Well, y'all have a good summer.
You too.
You too, Nancy. It's good to see you.
Yes, Paul, we'll have to get, this is what I was talking about. We'll have to get you on the Widgeo because for sure you and Vic can hook up. It's just, I call it like the limited Facebook for all of us. It's just kind of our group where we archive everything, but there's lots of things so I will send you a link to that tomorrow and get you on there. But you can definitely get a lot of feedback. So, yeah.
Good night, everybody.
Molly, did you want to talk about Sally? Good night. Yeah, but Sally, do you want to tell Molly, because the Peak program's yours, right?
I started it. If you look on the website, I based it, my PowerPoint will show that I based it on a book called Peak by Roland Smith. And it was perfect for our program because it was a fictional story about a young lad who wanted to be the youngest to climb Mount Everest. And then how it's more complicated than that, but it was a really good read and I just happened to think of it. And so it's been an exciting journey to work with a team to design curriculum and put it out. And I put, in my previous folder, I put out fact sheets. It's difficult to write curriculum between, and I put in the PowerPoint like a sandwich. And I said the sending homeschools are like a piece of bread. And then Peak is like the peanut butter and jelly or the whatever your favorite stuff is.
Good stuff.
So we could do, things like rock climbing. We could do authentic stuff. We used a lot of the messenger modules from the messenger program and did a lot with scientists from that mission. And we've just tried to use our local resources for our weather station. Plymouth State University has a very high quality meteorology department, so we use that. And so each year we try to incorporate local resources, and it's a team effort. So that's my phone. I'm going to ignore it, so I can do nothing about it. And so it just evolved with that. We learned from the first year how we could do it, and it's been growing ever since. It's really a privilege to have parents willing to have their students leave their curriculum, leave their homeschool, and go into a program like this. We did find we had to stabilize it by having the students keep their same math program and their same foreign language. So we're able to do a lot between language, arts, reading, social studies, and science and health. And we can play a little bit. And if it's real science, it has to be part of STEM, because if STEM isn't part of real science, I don't know what is.
How long is your program for? How long is the kids are in the program, and
they're in from November through March, 5 months. And then sometimes if they're 8th graders, then they go into, now we have a pilot program called Pinnacle, which is a high school program, and that's 10.5 months. They're graduating this June. But it's very intense, again, that they are there for the whole curriculum, and and the teachers there. It's a very small classroom. This is the first year for Pinnacle. It's been a growing year for them, and I'm not involved with that. I choose not to be. In a sense, I can put input. I think the 5-month program and my certifications in middle school curriculum stuff. So I stick with that. So, and it's different every year. You know, I just am amazed at what we can be able to do. So.
Totally look at Sally's slides. Unfortunately, Ricky's laptop was stolen with our recording of last month's meeting. So poor Ricky, he was just that was really awful. And we've been trying to figure out how to recover it. So we don't have a recording of Sally's reporting, but her slideshow is really, really involved. Okay. So lots of good information. So, you know, basically and as a homeschooler, I'm not meaning this tritely, Sally, but their program is a school so they have their own homeschooling programs, but then they come to Sally's school at Waterville for that really meaty, juicy school experience while they're training. And yeah, which is not so far from what I'm gathering, kind of what, I mean, you work with talented and gifted, right? You have kind of a very specific population.
Right. Sure. Yeah, mine's a pull-out program too, where they leave their homeschool and they come see us once a week. But it's for the whole school year, and it's unfortunately just for 3rd through 5th grade. So,
wow, that's really narrow.
And we also have a population. I teach, in a sense, 2 groups. The kids that that come in middle school, that I follow the homeschool curriculum, and I'm in constant contact. I shouldn't say constant. It's about a weekly, if not bi-weekly contact with the teachers. And once they understand that we're going to work with them together, and that we're really viable. You know, I used to think when I was in public school and I had a kid leave for what they call ski school, I used to think it was like a camp, and go have fun and have a ball and write a journal, and I would adjust the curriculum accordingly. But then I realized it's an intense program for the most part. And Waterville Valley is one of the oldest. The academy started in 1972. And the headmaster wants it to be the top sports academy, so that the parents who care about education also want that to be a very strong component. And our ratio of teacher students helps that, plus the diversity of teaching of the teachers there. We're pretty amazing as far as how we work together. So.
Well, sounds great.
Okay, well, I'll download that, and if you have any other questions, you know, we can talk or we can chat or whatever, and we can do that anytime.
Thank you.
Cool. All right.
All right, guys.
Good night.
Good night.
Good
All
luck,
right.
Molly.
Okay.
All right. Be well, everyone.
Okay. Thanks, Erin.
Bye-bye.
Bye-bye.
Okay, I guess I have to figure out how to leave. Oh, here it is, down here. Leave media.
Yep, down the
Okay,
corner.
bye. I'll tell you all about Maven, and how I can incorporate it with all the